So in this video we will be discussing about the threads asynchronous procedure calls. So APC is a function that executes asynchronously in the context of particular thread. When an APC is queued to a thread, the system issues a software interrupt. The next time thread is scheduled, it will run this APC function. So we'll be issuing the user mode APC, and in order for the thread to run that function, the thread should be in the alertable state. So here the thread to which queued is not directed to the function unless it is in alertable state. So the thread goes into the alertable state via these functions. So sleep x, wait for single object x, etc. So what we are going to do is, first we are going to write our shellcode into the remote process, and we'll be using the sleepx function for the thread to go into the alertable state. And in this alertable state, the thread monitors for this APC queue, and if there is any function in that APC queue, then it's going to execute that function. So I open the two projects. So one is normal sleep program. It will use the sleepx to go into 1 minute sleep, and it goes into the alertable state as well. So I have already implemented this open process. It's very nothing much. Process all access, inheritable false, and PID. Now we are going to write our payload into this process. So we'll be first allocating using virtual allocx. Into pointer.0, so the system will decide where to allocate. So the size, let's say 512 bytes. Allocation type, so mem commit and reserve, and the page production is page execute read write. So the value is just hexadecimal 40. Now the return type is the base address. Now we have allocated, we need to write our payload into that memory region. If base address not is equals to into pointer.0, then the memory region was committed. Then we can write the payload to that region. So we are going to use write process memory. I have already defined all of these functions in another file. So you can copy from pinvoke, or you can just copy from previous programs, or you can directly copy from pinvoke website. So let's go and write this one, and the proc handle, process handle, and the base address, and the payload dot length. And we are going to create a variable bytes return is equals to 0, and that will be out. Now we can place another check condition if bytes return greater than 0, but obviously the payload will be returned. So after that, what we need to do is, we need to call this function QueueUserAPC, and here the first parameter is the function's address, and the thread handle, and the parameter to the function. So it's very simple. So before getting the thread handle, we need to use open thread function. So I have already searched for these constant values and copied here. So these are similar to the process all access. So now we need to call open thread to get the thread handle. So desired access thread all access and inherit handle true and thread id, that is the thread id, we will be getting that using process hacker, and the return type is the thread handle. Now we can pass this thread handle to the QueueUserAPC function. And the function address is the base address. At that base address the our shellcode resides. And the thread handle which we have got recently, and the function parameter is null. So I think we are good to go. Now here we have first input. So if I go and run this one, so let's stop here and put a breakpoint at this, and let's also put breakpoint just after the write process memory, and we can get the process ID. So if you want to inject into other processes, you can inject as well. So you can loop over through all the threads and identify which thread the which thread that process belongs, which process that thread belongs to, and then you need to wait until the thread goes into alertable state. Otherwise your shellcode not gonna execute. For demonstrate purpose, I am going to create another process, and the process PID is this one. Copy this and paste it here, and the thread ID is go to threads, and here you will have the thread ID. Copy this one. So we have process ID and thread ID. We are going to open the process and execute, allocate some memory and writing the payload. So let's run this, and if you go and see, okay, so we are not printing anything. So let's go and print remote base address. You can also check in the process hacker for read, write, execute regions. So let's run this, and let's close this one and open another memory window, that is memory 2. So memory 2 is this process. Now copy the thread ID, and now let's run this, and you have the base address. So if you go to this, and we will have this calculator payload. So let's go ahead and run this one. Now the program is waiting for our input. Now you can directly go and queue this APC function. So let's continue this, and let's exit. So we have queued the APC function, and now if I go and hit enter, this thread will go in alertable state and our payload gets executed. So now we can see after I gave this input, this function goes, our thread goes into the alertable state by this function and our payload gets executed. So you can also now let's go into this reap mode, alertable state. Now our program is in alertable state. Now we can go ahead and directly run this to pop up the calculator. So that's how you queue the user APC to a thread, and the thread must be in alertable state to execute our payload.